Okay, so this is chapter 2, and this is called Uses and Misuses of basically of statistics. So this is how you can sort of cheat your opponent or um, confuse your opponent or confuse someone, or how certain ways that you can mislead people, or in other words, you want to know how you could be misled. Okay, so the first thing is called truncating the axes. So graphical analyses are an important part of statistics. So graphical analyses like these. This is what you studied, partly what you studied in chapter 2. This is called a histogram. So they're important. Um, However, graphic software allows people to change the appearance of any graph. Thus, one needs to be careful when reading a graph in order to interpret the data properly. As an example, consider the following data on the number of identity theft cases per 1,000 people in 8 states of the United States during the year 2005. So identity theft, means like if somebody gets your identity, they might act as though they're you online, and that can cause you a lot of trouble. Okay, so it's called identity theft. And these are 8 United States states: Arizona, Nevada, California, Texas, Colorado, Florida, Washington, and New York. And this comes from something called Identity Theft Security 2008. Okay, so what does this mean? What does this number mean? The number of cases per 1,000 people in Arizona. So there were 156.9 cases per 1,000. Obviously, Arizona has more than 1,000 people, but this is the number per 1,000 people in Arizona. In Nevada, it was 130. In California, it was 125. In Texas, and so on. Okay, so per 1,000 people, where does identity theft occur most often per 1,000 people? In Arizona. Okay, now let's make a bar graph, not a histogram, sorry, a bar graph of this data, and we get this. Okay, so Arizona is the highest, and so on. In addition to being able to obtain approximate rates by looking at the vertical axis, so if you look at this, you can get the approximate rates of Arizona. It's just under 160 per thousand. This is about 130 per thousand, and so on. So in addition to being able to obtain approximate rates by looking at the vertical axis, we can determine the relative size of the rates by looking at the bars. For example, we can see that the rates in Colorado and Florida are approximately the same, whereas the rate in Arizona is approximately 50% higher than the rate in Washington and New York. Is that right? So Arizona, Washington, and New York, it's maybe close to double. Okay? However, we can present the same data using a bar graph similar to this one that we just saw. The data have not been altered in this graph. However, the vertical axis has been changed so that it begins at 80 instead of at 0. So of course here it begins at 0, but here it begins at 80. So if someone gave you this graph, it's not wrong, it's correct. But if you look at it, what do you see? What might you conclude? That Arizona is kind of double or almost double Nevada. But the difference is what? Just 160 versus 130 something. So it's not anywhere near double, but it looks like it might be. Arizona appears to be 8 times the height of the bar for New York. Okay. This would correspond to an identity theft rate that is 700% higher for Arizona than for New York, when it is actually only 50% higher. Similarly, the rate for Texas appears to be 300% higher than for New York, when it is really only slightly more than 30%. So you can see that if you start it at 80, you can make it look like this, and that's possible. Then it's possible to mislead people. There are many reasons why the second version of the bar chart might be used. In some circumstances, the creator of the graph may not know any better, so they might have just done it by mistake, put this at 80. In other cases, it could be that the user has ulterior motives, such as to justify increasing funding for fighting identity theft, or to make a state or a region appear to have a lower rate than what it truly is. So here, you might be misled into thinking that New York has a very, very low identity theft rate, like only 1/7 of Arizona. So then you don't have to fight it as much. Okay? And one more example of how graphs can be misleading. Problematic graphs also occur because the user does not understand the purpose of a specific type of graph. For example, suppose the above data on identity thefts were displayed in a pie chart, such as the one shown here. Now remember, for a pie chart, you're supposed to include all possible sources, not just part. But you could make this pie chart from this data. Okay? There are many possible misinterpretations of the data as a result of using the pie chart. For example, a person might look at the graph and believe that 17.4% of all identity theft cases occur in Arizona. And that really, if you displayed the data like this, which isn't exactly wrong, but you're not supposed to use a pie chart in this case. But if you did, it would certainly lend itself to being interpreted as that 17.4% of all identity theft cases occur in Arizona, but that's definitely not the case, even though this graph makes it look like it is. There are two major problems with this interpretation. First, only 8 states are represented in this chart, so all the percentages are overstated with respect to the entire United States. So if you only have 8 states, then they're all going to be higher. Second, so that's one part of a pie chart rule, is that you have to include all possible sources of the data. Second, and more important, the percentages are overstated. Second, and more important, the percentages are based on the sums of the states' rates per 1,000 people. This cannot be done unless all the states have the same population. So what this means is that this is 17% of Arizona. But Arizona has a lot less people than California. Okay, so 13% of California's population is a much greater number of people than 17% of Arizona's. So you might be misled into believing that Arizona has more people participating in identity theft, whereas in fact it's going to be California, because California is much, much bigger than Arizona. Maybe it's like 5 times the population or 6 times the population. So it's going to be a lot more people, but the percent is smaller. The percent of Californians is smaller. Okay, so you can read that here. Okay? Okay, that's all.